Okay, in this video I'm going to talk about how resistors behave in series. So let's just remind ourselves what series means. Series means one after another. They go in order. So let's say that I have a wire here going along like this, and in that wire I'm going to have some resistors. So again, the resistors look like this. Okay. I mean, sometimes like the International Baccalaureate will do boxes, but typically resistors look like this. And let's say that this is R1, and this is R2, this is R3. Oops, this is R3. And I want to know, how do these behave? If they were one resistor, how would they behave? Well, would the resistance go up? Would it go down? What would happen? So if I had let's say that I put a box around this. I'm going to put a rectangle actually around it. I want to do a rectangle. Say that I put a rectangle around this, and I said, okay, if these resistors could behave as if they were one resistor, how would they behave? Would they behave well, or would they behave bad? Would the resistance get larger, or would it get smaller? So in other words, if these resistances could be turned into one large resistor, which we will call the equivalent resistance, okay? If I made them into this equivalent resistance, how would they behave? What would be the result of that? Would it be larger? Would it be smaller? What's happening? So let's just say I made R1 equal to 1 ohm, because resistance is in ohms, okay? R2, let's make it 2 ohms. And R3, let's make it 3 ohms, okay? So if all of these acted together, what would happen? Well, you're going to increase the resistance as you go. So the total resistance of this would be the same as if you added all of them up. So the equivalent resistance is 6 ohms. Okay, 6 ohms. So there's a rule for resistors that are in series. The rule is this, that the equivalent resistance is going to equal the sum of the smaller resistances. So R1 plus R2 plus R3, like that. Okay, so the equivalent resistance is going to equal the sum of those. So 1 plus 2 plus 3. So the REQ in this case was 6 ohms. Now that's very important, because we're always trying to take resistors and break them down into one resistor in the end. That's the optimal thing to do. So we want to get one resistor, one battery, if we can, to find out what's happening with the current leaving the battery. Now we reviewed before, we said that, okay, that the current going across is constant for all of these, right? That we know that the current is going to be the same in all cases, right? So we saw that in the last video. So let's say that the current here was, let's just say it's 3 amps here. Let's say the current here is 3 amps, the current here is 3 amps. That we know that the current is going to just be constant throughout. So that means that the current across this one here is going to be the same thing. It's going to be 3 amps going across that big one too. So I can find the total voltage drop across the whole thing, or I can find the voltage drops across each little one. And when we get into Ohm's law, we'll talk about how to find that voltage drop. I talked a little bit about it before when we talked about Ohm's law, which was V equals IR. But we'll get more into depth later. But the correct interpretation of Ohm's law is really delta V equals IR. We're talking about the drops across these resistors as we saw in the last video. But all of these behave as one big resistor.